Carter, what's number 1? 10 to the 3rd. Very good, Carter. Hannah, 2.
5 to the negative second equals 1 over 25.
Thank you. Grant.
Yes. 10 to 0 power equals 1.
Good. Drew.
1/4 to negative 30 equals 16.
Thank you. Any questions? You guys are getting pretty good at this, right? 3rd day, it's starting to click, hopefully. Skylar. Thank you. Questions? Ben?
Log base of 20, or log
That's right.
base of 20 of 1 over 20 equals negative 1.
Good. Morgan?
Log base of 216, 6 equals 1.
Good. Libby? Good. We're starting to get the hang of those, right? Those are the easy ones, right? Hopefully. And we're going to do this, Josh, which you're good at this, right? Okay. We're going to do that to do these. What do we have to set all these equal to first? X. Put equals X for all of them. And then we're going to rewrite these exponentially. So what's the base? 4. What's the exponent? Equals 256. Now, the goal here is to have the same base on both sides. Can I do 256 with a base of 4? Yeah. 4 times 4 is 16 times 4 is 64 times 4 is 256. So here's the problem now. 256 is 4 to the 4. So since these are the same base, I can say these two exponents are equal. So my answer is 4. Okay. This one. What do we say when that's a 1? 0 every time. Okay. So that one you should just recognize. That's 0. Okay. This one. 2 to what power is 1 over 32? So I got to try to make that 32 with a base of 2. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. All right, but this one's a little different because the 32 is in the bottom of this fraction. So how do I move the 2 to the 5th out of the bottom? Make it negative 5. Right. Move that exponent 5 and make it negative. So it's 2 to the x equals 2 to the negative 5. Those two are the same. So now that I have the same base in the right spot, I just say x equals negative 5. This making sense? All right, this one's got a 25 to the x. And that's 2/10. You're late.
I know.
You can sit next to Ben. Not down. Thanks. So you guys understand that 0.2 is 2/10 as a fraction, right? You're going to answer me? Yes?
Yeah.
Okay. Can I reduce 2/10? 2, 1/5. Can I use 5 with 25? What is that? 5 squared. And since that's x there, what's that do to that exponent? Just puts an x there, right? So what's exponent here? 1. So what do I got to do to move it up? Negative 1. You following me? Just like we did here. 2 to the 5th in the bottom, moved it up, make it 2 to the negative 5th. So Now it's not just x, though. That's where this is a little different. It's 2x equals what? -1. So you got to solve this little equation. What do I got to do? Divide by 2. So it's -1/2. So the trick, a little bit different there, is we did 5 squared for the 25 with that x there, so it makes it 2x. So it's 2x equals 1 instead of -1 instead of x equals -1, like we've been doing. Okay? Questions? These are really easy. What did we say ln was? What's the base for ln? Natural log. What's the base? E. Thank you. All right? So remember, this is the same as this. So what happens to those? Cancel. What's the answer? X cubed. What happens to these? 13, log base 13, cancel. So it's a 6. Don't have to do anything on those. Really easy. So when you see ln and you see an e after it, they cancel each other out. Natural log of e is 1. Okay? 19 is the same as these, except a little bit tougher because you got to figure out what base to use. Okay, so we're going to do the equals x stuff. Right? So 16 is the base. To the x power is 64. 81 is the base. To the x power is 27. 16 to the x power, 32. 27 to the x power. Everybody's okay that far, right? These are a little tougher because we got to turn these both into the same base. On the other ones up above, we already had one of the bases they gave us, right? Usually a 5 or 3 or 2 or something. Okay? This one we could use 4. 4 to what is 16? Second. So then there's an x with it. 4 to what is 64? 3. So now I have to say what is equal to what? 2x equals 3. And then divide by 2. So it's 3/2. What number can we use for 81 and 27? 9. You can't, 9 times 3, but there's not a 9 times 9 again, right? So we have to go smaller. 3. Yeah. 3 to the 4th is 81. And then there's the x. And 3 to the 3rd is 27. So now we're going to say 4x equals 3. And then divide by 4. So that answer is 3/4. Right, Emma? Okay. Making sense? What can I use here? Can I use 4 again for, can I use 4 for 32? No. So I got to go smaller. 2, yeah. 2 to the 4th is 16, so it's 4x. And 2 to the 5th is 32. So it's 4x equals 5. So that one's 5/4. All right. What did we use before for 27? 3. 2 plus 4 is 6 plus 3 is 9. Does 3 go into 9?
Yeah.
Yeah, so 3 goes into this. Okay? So we can use 3 cubed, so it's 3, the 3x. We did 3 to the 4th is 81. What's 81 times 3? 243. So it's 3 to the 5th, this one. So you got 3x equals 5. Divide by 3. So those are a little tricky. because you had to figure out what base to use. And again, a lot of times it's 2, 3, 4, or 5 usually. One of those 4. Okay. Any questions? Okay, little practice on 6-2 stuff. What do I do with the exponents? Add. What's negative 9 plus 12? 3. What goes into 25 and 35? 5. What's 25 divided by 5? What's 35 divided by 5? Where's the higher exponent for the e's? Bottom. So the e stays in the bottom. And then what I do with those exponents? Subtract. What's 7 minus 2? Okay. What's the 4th root of 16? We've been doing it a few times. 2, right? 2 times 2 is 4, times 2 is 8, times 2 is 16, right? Just divide 24x by 4. What is 24x divided by 4? 6. X. Okay? And then here's where some of you made a mistake. You just tried to multiply those, which is right. But a lot of you just put 2 there. It's 2 to the 5th also. So that should be a 32. Okay. Some of us forget. We remember to multiply these, but we forget to take the 2 to the 5th power sometimes. Now I go 32 times 2 is 64. E, and then what do we do over here with them? We add it, right? And that's what we're doing here. Negative 15x plus 1x is negative 14x and plus 1. Okay. Questions? Now, you guys got from 6-1, when the parentheses had a number that was bigger than 1, it was what? Growth. And when the parentheses, what was in it, had a number less than 1, what'd you say it was? Decay, right? So some of you were thinking that on this one, I think. Okay, but that's, all of these have the E, all right? So what we look at is the exponent. If the exponent's positive, it's growth because of the E to the power. If the exponent's negative, it's decay, right? So this is a negative 2x exponent. This is decay. This is a positive 4x exponent, so that's growth. Don't look at the 0.75. That's not what's being raised to the power. Okay? Positive, so that's a growth. Exponent, negative exponent, that's a decay. Simple. Yeah. So yeah, you didn't have to graph those. If you had to graph it, you just put in your calculator, right? And sketch. All right? But I don't think I'm making you do any graphing on the practice quiz or the quiz. So that's what your assignment is today, is the practice quiz. We'll go over tomorrow your quiz. Your first grade of the last 9 weeks is Monday.
Can't believe I'm surviving this long.
There's 2. Yeah.
I'm be dead right now.
It's so Christian.
I'll be sober.
I thought you were chilling. Josh thought it was dead. What do you say? That's all right. Say again. I'm getting to it. I knew it was one. Not now, but I could.
Which problem? You want to take them? You got them? He's like zoned out. I was zoned out. Everybody get one? Sure. No way. I'm here. I'll do it real quick, bro. What? Right. Right. I didn't throw it. Oh,
No.
Well, the elbows were tough.
Thanks.
You make almost $1,000 bucks. $1,000 bucks.